Question number 11. The polynomial function h has a degree of 3. Which of the following tables could be representative for h? The idea of solving this kind of problem is we want to form first order, second order, third order, and so on and so forth of the rate of change. If it takes the nth difference to get the constant rate of change, that means your degree of the polynomial will be nth degree. Now let's look at the first table. In this table value, you have the delta x is constant, that equals 2. So we just need to add, look at the delta h without actually divide delta h by delta x, just to save some computation time. Let's do the difference. You would have first one is 0, the second one is 4. Notice that you have to take the difference following the same order. That means use the second one to minus the first one, then you have to use the third one minus the second one, so on and so forth. You should not switch the order in the middle, so that will give you the wrong answer. Let's continue on to finish this first order difference. That will be 9 minus 2 equals 7, 9, 18, that gives you 9, and 18, 28, that is 20. This forms the first order difference. Now you take the difference of the first order difference, you would get the second order difference of rate of change. That will be 4 minus 0 would have 4, 7 minus 4, 3, and 9 minus 7 is 2. Notice that I already made a mistake here, so this term should not be 20, it's 1, so that will give you the second difference, 1 here. You'll see that if you make any mistake in calculating the difference, that will lead you to a wrong conclusion. So you must be very careful not to subtract the numbers incorrectly. Now we can see that the second order difference, 4, 3, 2, 1, that forms a linear sequence. But let's finish the third difference. That will give you 1, 1, 1, that is constant. So it takes first, second, third, 3 steps of differencing to get you a constant rate of change. That means the original polynomial has possibly a degree of 3. The correct answer of this question would be the first one. Some students got wrong by selecting the second option here. So what is wrong with this answer here? If you look at delta h, will be 28, 20 minus a, then minus a again. You have minus 7, minus 5, and minus 2. Now you continue on to form the second order difference. You would have 0, 1, 2, and 3. And if the third one, you would have 1, 1, 1. Because the original function of h is a third order polynomial, and it takes 3 steps to get a constant, you would conclude that this would be the value for h of x. But this is an incorrect answer because in this table, the delta x is not constant. You can see that delta x equals a, then becomes 16, becomes 14, and 20, and 4. So delta x is not constant, so you have to divide the delta h by delta x to get the correct rate of change. So when you divide by delta x, you will not get a constant third order difference. So this table is not the correct answer.